All right, hello everyone. Back for our next installment of video of looking at the rafter math. Moving forward, I will attach one more quiz to this video, to the email with this video in it. That's one more than we normally do. This is usually our last quiz, but that's because you get more math examples down in the lab, and then we lay those out. And you get the experience of laying it out, which helps you understand the math more thoroughly because you're proving the math to yourself while you lay it out. And you get to actually set rafters, so therefore understanding the construction more thoroughly and how all the parts and pieces come together, understanding the geometry more thoroughly. And when we're up there, I also have one lab devoted to building a little mock-up. Obviously, you guys don't get any of that lab experience, so that's why we're taking the steps we're taking. So in addition to that, in addition to all the other steps, we're going to have one more video where we'll go over some rafter math. So we will go over this math, this quiz that you guys all have received and completed, and then we'll go over one more. After that, the last test, it would normally be the second test. Again, obviously, we can't do the hands-on final exam. Okay, but the second test, the last test before the final exam is a math test with everything that we've covered, stairs and rafters. Okay, now I still haven't decided if and how I'm going to grade that. Okay, don't worry, I'm not going to be tough on you no matter what. Okay, I'm going to be fair no matter what because you guys are missing too much of the experience that you need. And so therefore, no matter what the situation is, but that being said, some of you need a good grade on that to help bring your grade up from that last test. Okay, so I'll have to look at all of that. Okay, so but for right now, don't worry about it. I'm just going to deliver that exam, take the exam, do your very best, and then we'll move forward from there. Okay, so don't panic about anything. Just give everything your best shot. Okay, and that being said, you should be completing all of this math. Okay, number one, you need to understand it. Number two, you need some type of a grade on that final exam. All right, so basically that's it for this. So again, we're going to go over this exam right here. This quiz right here, those rafters right there. Okay, and we will walk through the answers as we move forward. You can see that I put them up here. I just abbreviated them. Common 1, hip 2, valley 1, jack 2, jack 7. Okay, we've looked at every type of math, whether it be a common, a hip, a jack. Okay, so at this point, we're just practicing going through several examples of all of those different types of rafters and understanding both the geometric concepts and understanding the algebraic concepts that we use to solve for that geometry. All right, so starting with our common number 1. Okay, again, the 4 things I need are A, B, C, and run. Okay, run is an easy one. We can all see nothing has changed. It's still the same roof plan. We've got our 16-foot span, so that means that half of that is 8 foot. And again, geometrically, you should be able to see that in plan, understand what that means. That's my horizontal run, in plan, in level. Okay, all the things that we've talked about. All right, my C, I need to solve for that. We can see that we have a different pitched roof this time, so I have 10 inches of unit rise. But because my rafter hits the top plate at what? At 90 degrees, one of these commons right here, because it hits the top plate at 90 degrees, my unit run is 12. So I solve for that C. So C squared equals 10 squared plus 12 squared. So C squared equals 100 plus 144. So C equals the square root of 244. So C equals 15.62 inches per foot of run. Okay, again, math we've already done several times. Okay, so 15.62 inches per foot of run. All right, okay, everybody sees that. From there, we solve for our A and our B. Again, my formulas never change no matter what the rafter is. So A equals C times run, that equals 15.62 inches per foot, times my 8 foot, my feet cancel, and I get 124.96 inches for my A, and I convert that to feet in inches, that is 10 foot, 4 and 15/16 inches. Okay? All right, so that's going to go right here, 10'4" and 15/16 inches. Okay, now I solve for my B. B always equals C times my overhang in feet. So that equals 15.62 inches per foot times what? Okay, again, I go back to my print. I have a 20-inch overhang this time, so 20 divided by 12. Okay, so that would be 1 foot 8 inches or 1.67 feet. Okay, my feet are going to cancel. Okay, again, you got to read your information carefully. Some of you might have made a mistake there. 26.085 inches converted to feet and inches equals 2 foot 2 and a 16th. Okay, so 2 foot 2 and a 16th. Guess I should be putting it there too. Okay, so 2 foot 2 and a 16th. Okay, so we've established a couple of things. Okay, just like we've seen with all of our other math, I do not need to solve for the C at 90 degrees again. No matter where I hit on my roof line, it's going to be 15.62 inches per foot. So we'll see that my math gets a lot easier as I move forward. Okay, and I've established one of my tails. Okay, so again, the question is, so the question is, do I hit the top plate at what with each of my rafters? 90 degrees or 45 degrees? It's a common, so I'm hitting it at 90 degrees. Okay, so a hip, nope, that's 45 degrees. Valley, nope, that's 45 degrees. Jack 2, yes. I look at my plan and I see Jack 2 has got the same tail as my common. So 2 foot 2 and a 16. Okay, all right, how about Jack 7? Okay, we look at my plan and what do we see there? Jack 7 does what? It doesn't have a tail. So our third option, 0 foot 0 inches. If that jack, I look at my Jack 7 right here, okay, right there. If that jack were to continue all the way to the top plate, it would hit it at 90 degrees. Therefore, my C is correct. Okay, but obviously, I can see it doesn't have a tail. And if you remember all the way back to our terminology, that's why Jack 7 and Jack 6, okay, any of those jacks in that area are technically called a cripple. Okay, a cripple takes me from rafter to rafter. A jack takes me from rafter to top plate. Okay, I do it, tend to call anything other than a common, a hip or a valley, a jack. Okay, and the term really is cripple jack. So everybody tends to call them all jacks. Okay, but technically a jack goes from a rafter to the top plate, and a cripple goes from rafter to rafter. Okay, so just a technicality, but again, that means that we have a third option here. Okay, so if I'm hitting my top plate at 90 degrees, all of my tails are going to be the same. If I'm hitting the top plate at 45 degrees, all of my tails are going to be the same unless I don't have a tail. Okay, so be careful. You should be able to see that as you're walking through. And again, ultimately, what are we talking about? We're talking about the ability to interpret the print. Analyze, interpret, understand the print. Okay, and again, they give us that information different ways. They give it to us graphically. We're solving for it mathematically, but they give it to us graphically, and I should be able to see and deductively reason that there is no tail there. Okay, so again, a third option. So either I'm hitting my top plate at 90 degrees, I do have a tail. I'm hitting my top plate at 45 degrees, I do have a tail. Or if I were going all the way to the top plate, I'd be hitting it at 90 degrees and I don't have a tail. Okay, all right, so moving forward, next rafter is going to be our hip 2. So rafter hip 2, still need the same 4 things every single time. I need my run. Okay, so I look at my hip 2 down here. Okay, on that smaller roof line. Again, we've already solved for this run several times. Half of 9 foot 4 is going to be 4 foot 6. Half of 2 foot, or half of 4 inches is going to be 2 inches. So 4 foot 8 inches or 4.67 feet for my run. Okay. Okay, I'm hitting the top plate at 45 degrees, so I have to solve for that C again, 16.97 inches. So C squared equals 10 squared plus 16.97 squared. So C squared equals 100 plus 287.981. So C equals the square root of 387.981. So C equals 19.70 inches. Okay, 19.70 inches per foot. So I put that right there, 19.70 inches per foot. Okay, so now again, math doesn't change. A equals C times run, B equals C times overhang in feet. So A equals C times run, that equals my 19.70 inches per foot times my 4.67 feet. Okay, and again, so that works out to 91.999 inches, which when converted back to feet and inches is 7 foot 8 inches. Okay, so 7 foot 8 inches right here. Okay, then I solve for my B. B equals C times overhang in feet. So that equals 19.70 inches per foot times my 1.67 feet. Again, I've got a 20-inch overhang this time. Okay, so that comes out to 32.899 inches. Convert back to feet and inches, and I get 2 foot 8 and 7/8. Okay, 2 foot 8 and 7/8. That goes right here. And again, now I can say I don't have to solve for that C again. Okay, it is always going to be 19.7 inches per foot. 19.70 inches per foot. Okay. All right. And I can see that I can continue to fill in the right side of my chart. Okay, Valley 1 hits the top plate at 45 degrees. Hip 2 hits the top plate at 45 degrees. So those tails are going to be the same. And again, I should be able to see that in plan. Okay, all of those tails are the same. All right. Okay, so now it gets even easier. Now I can just start to walk through, and I only have to solve for the A dimension of each one of my rafters. Okay, so Valley 1. So once I solve a couple of rafters, the only thing I really have to worry about is determining my run. As long as I'm right with all of my math, of course, but all I really have to do is determine my run. So Valley 1, I look at Valley 1, okay? Where's the width of the building for Valley 1? This valley runs all the way to that peak down to that top plate. It's a part of this big rectangle. Whereas Valley 2 is a part of this square, if I can continue it on. Okay, I can see that that valley is the same length as that hip. And that valley is the same length as that hip, and that hip, and that hip, and that hip. So it's part of this big rectangle. So this is my span right here, my 16 feet. Okay, so my run then, therefore, is 8 feet. I know my C, I'm hitting the top plate at 45 degrees, 19.70 inches per foot. I know the B, I'm hitting my top plate at 90 degrees, so 2 foot 8 and hitting the top plate at 45 degrees, so 2 foot 8 and 7/8. So again, now all I have to solve for is my A. A equals C times run. Okay, so 19.70 inches per foot times my 8 feet. Okay, so I walk that through, and I get 157.6 inches. I convert that back to feet and inches, and I get 13 foot 1 and 5/8 inches. Okay, so 13 foot 1 and 5/8 inches, and again, that's all I really have to solve for. I just have to determine my run. I I know my C, I know my B, and I just have to solve for my A. Okay? So again, understanding the geometry and understanding the algebra in order to solve for that geometry. All right, we are on to what? Our Jack 2. Okay, and what did we say our jacks are based on? Our jacks are based on our on-center spacing. Okay, so again, we've got our 16-inch on-center spacing. Now be careful. Okay, another option is what? 2-foot on-center. Very common with rafters. Okay, I haven't given it to you that yet, but watch for it. Okay, and again, that means I've got to read my specs. Okay, my overhang has changed, my pitch has changed. Okay, this has stayed the same, but it could change. Okay, but it's not. It's at 16 inches on center, same as we've seen last time. Okay, so I'm looking at jack number 2. Okay, right there. So again, it's 16 inches from here to the first jack, another 16 inches from here to the second jack. Okay, so that means it's 32 inches, and I know that's a 32 by 32 by 32 square. So my horizontal run is 32 inches. Okay, it's 32 inches, but that has to be converted to what? To feet. Okay, so that means that I have 2.67 feet. 2 foot 8 inches. Okay, 24 inches in a foot. Okay, plus 6 plus 2, 8. So 2.67 feet for my run. Okay, again, only difficult thing to determine now. Because I know my C, I'm hitting the top plate at 90 degrees. So 15.62 inches per foot. I know my B because I'm hitting the top plate at 90 degrees. So 2 foot 2 1/16. Now all I have to do is solve for my A. A equals C times run. My C is my 15.62 inches per foot. And my run is 2.67 feet. Okay, cancel, cancel, and I get 44.108 inches. Convert that to feet and inches, and I get 3 foot 8 1/8 inches. Okay, 3 foot 8 1/8. Okay, all right. So last one is my jack number 7. All right, starting to get a little more difficult here. I really got to start thinking about things now. Okay, I've got my jack number 7 right there. Okay, everybody look at your quiz. Okay, if I look at that jack number 7, okay, what can I say? Can I say that ridge that's running through, that's a ridge right there. Okay, the ridge board, again, we got to think about it in elevation right now. That's the ridge board right there. That's running across and coming right in the what? In the center. How can I be 100% sure that it's in the center? If this is built correctly, it absolutely has to be, because I have what? Only 45-degree triangles everywhere. Okay, if it's a 45-degree triangle, it has to be splitting the center of those two rafters. Okay, so from there, what can I say? How far apart are those two rafters? They are 16 inches apart. Okay, and if they're 16 inches apart, and I see that jack 7 right there is going halfway through that 16 inches, and the other jack 7 is going halfway through that 16 inches, because I know this ridge is in the center because it's a 45-degree triangle right there, those little tiny triangles that I can see. So therefore, I can be 100% certain, if this is built correctly, that my run is what? Half of 16 inches, which is 8 inches. Okay, so my run, again, the only thing I have to think about is 8 inches. Okay, but I can't keep it in inches. I've got to convert it to feet. So 8 divided by 12, 0.67 feet. Again, I know my C, because if I carried that rafter all the way through, I'd hit the top plate at 90 degrees. So it's 15.62 inches per foot. Okay, I know my B, if I had one, would be 2 foot 2 1/16. Okay, but I can see, obviously, because it's a cripple, not a jack, okay, and it's a crippled jack, not just a jack, that I do not have a tail. So my third option, 0 foot 0 inches. So, but again, all I have to do now is solve for my C. A equals C times run. 15.62 inches per foot times my 0.67 feet. Okay, cancel, cancel. And what do I get? I get 11.068 inches. Okay, what's that mean? What do I divide by? Okay, that means I'm going to divide him by what? Okay, am I going to divide that whole thing by 12? No, because I'm in inches and I'm less than a foot. So I know I have 0 foot, 11, and I'm going to divide him by 16, and I'm going to get 1/16. Okay, again, my units mean things to me. Okay, that's why it's so important to understand and keep your units as you're working through a math problem. Your high school math teachers told you that incessantly probably, and you blew it off just like everybody else in high school. Didn't think it was a big deal because all you were doing was solving a math problem. Now it matters. Okay, I need to understand if I'm in feet or if I'm in inches, if I'm in feet and inches, if I'm in decimal feet, if I'm in acres, if I'm in cubic yards, if I'm in square feet. It really, really matters now. Okay, because I'm attaching cost to it. I'm trying to get a job. I'm attaching schedule to it. I'm trying to determine how long it's going to take me to do that job. Okay, I'm trying to determine how many laborers I need on that job, what types of equipment I need on that job. Now it all really, really matters. Okay, most of you have done an internship by now, and you're starting to see the sophistication of the commercial world or the civil world. Well, all of you guys would be in the commercial world. Okay, you understand it. There's millions of dollars flowing through that job. That's a really big deal. That means you either keep your job or lose your job. You either succeed in your job or you don't succeed. Okay, and our math is a huge part of that. Okay, so again, now my units really mean something to me. And I have to be able to deductively reason, okay, and walk through that math problem and understand what I need to understand. Okay, I can see I'm below a foot. So I know I have 0 feet, 11 inches, and a fractional portion of inches. So I would have to multiply by 16, divide by 16, not divide by 12. Okay, so my A is 0 foot, 11 and 1/16 inches. Okay, all right, so that's your second to your last quiz. We're almost done with the semester, guys. Crazy, crazy, crazy. And no, I'm going to see maybe some of you at OAK this summer. I forget if anybody's doing an internship or not. I know a couple students are full-time hired. A couple of my seniors are full-time hired. So, but if not, again, I know this is terrible, but hopefully this is working halfway decently for you, and you're able to get the math to the greatest degree possible, and it's making some sense to you. Again, what's most important, and this is what you're losing the most, is the geometry. Okay, that's what we deal with in construction, is geometry. Okay, we use our algebra to solve what we need to solve for with that geometry, but it's the geometry that we first need to understand. I have to have the ability to understand the shapes that I'm dealing with. Okay, whether that be a rectangle, a square, a triangle, what type of a triangle is it? Okay, they define our slope for us. That tells us what type of a triangle it is. Okay, I need to be able to understand it in plan. I need to be able to understand it in elevation. Okay, I need to be able to understand it underground. Okay, that would be an elevation, but it would be subgrade. Okay, we deal with piping, and piping can, a lot of our piping is at a slope. Okay, just our excavation can be at a slope. Okay, so again, that's a triangle. I need to understand that triangle. I need to be able to understand it in elevation, understand it in plan. Okay, so again, that's what we're talking about here. It's our math, understanding the geometry, and then from there, understanding how we have to apply our algebra or maybe trig. Okay, you start getting into the exterior stuff, we're talking more trig. Okay, but again, being able to understand how to apply that math to our geometry. Okay, very, 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 very important. If you don't understand it, you don't understand how to read the print. If you don't understand how to read the print, you don't know how to set up a job. You don't know how to estimate a job. You don't know how to run a job. Okay, so that's just part of the learning process for you guys, and hopefully you're getting it. Hopefully you're getting. Go ahead and give me some feedback. If you're doing okay with this and the math is making sense to you, and you're understanding the geometry, not just the algebra, let me know. Just reply to one of my emails and tell me if this is working for you guys or not. All right. So again, one more video with another quiz, and from there, there'll probably just be communication via email, and we'll take that final exam. I am planning on driving up to the Granger building, okay, probably next week once things calm down a little bit, and I'm going to have my son video me laying out some rafters. Okay, so again, probably for that, I'll just require that you watch it, okay, which means you'll have to prove to me that you watched it. Okay, just send me a video and say that you watched it. And again, it's not nearly as good as you guys doing it, okay, actually laying it out with your own hands. You guys already know that. That makes a huge difference, okay, but at least you'll be able to see it, and hopefully it'll make some of this make more sense. Okay, so we're doing everything that we can do to try and get through this crappy situation, and we'll continue to do that. All right, see you next time, guys.